we are going to investigate the limit as x goes to infinity of x squared over 3x. Now, I know that you could simply divide off an x, correct? But suppose we didn't divide off an x, okay? Let's look at the functions and what's happening, okay? The limit as x goes infinity of x squared over 3x. I'm going to draw a line to represent 3x. You'd think after a while I would learn, and I just don't. Hello. Hi. Striffy boy. Oh, it is optional Monday. So, what's that? He did. Striffy scored 48? Really? Against the Watna? Good for him. All right, as we glance at this function, you can see that the line sits on top of the parabola, correct? The line sits on top of the parabola. They're pretty close together, aren't they? And if two values are pretty close together and you divide them, what about do you come up with? You come up with about 1, right? Okay. And so your first inkling as you look at the limit as x goes infinity of x squared over 3x might be to say, well, that's going to be infinity over infinity, which is 1. Okay, that might be what you want to do, but that is in fact not correct. Because watch what happens here, okay? As I move further towards the right, as x approaches infinity, what happens to the distance between the parabola and the line? It continues to get larger and larger and larger, doesn't it? And so therefore, in this case, infinity divided by infinity comes out to be infinity, okay? And there's an easier way to deal with these, what we call indeterminate forms. And this is what it looks like. L'Hopital's rule. Given the following conditions, suppose f of x divided by g of x is infinity divided by infinity, or 0 divided by 0. These are what we call indeterminate forms. And indeterminate forms, namely, good morning, how are we doing? Congratulations on your 48. Okay, that's all right. I agree. Teachers should build their schedule around your lives and not their own. Then that's your issue. Okay. Back to indeterminate forms. You don't know what infinity divided by infinity is. Maybe it's 1. Maybe it's 0. Maybe it's 5. You don't know. In this situation, 0 divided by 0. 1, 20, 15. You don't know what it is. We cannot simply say, well, infinity divided by infinity is 1. So how do we work through indeterminate forms? And please note, there are more indeterminate forms than this. You could also have, say, infinity times 0. What is that? Is it? Is it really? Maybe the infinity wins out over the 0. It can happen, okay? So there's other indeterminate forms, but L'Hopital came up with just a genius way of working through these situations. You may do this. take the derivative of the top, the derivative of the bottom. In this case, I say x approaches infinity. It doesn't have to approach infinity. We can approach many different numbers. But if you come up with an indeterminate value, you could simply take the derivative of the top and the derivative of the bottom, and that will find for you its limit. Look at example 2. It says the limit as x goes to 1 of the natural log of x over 1 minus x. Anybody know what the natural log of 1 is? It is 0. So we end up with 0 over 0. Many people look at 0 over 0, they say, well, that's going to be 1. That's not true. It's an indeterminate form. We don't know how to solve it. But fortunately for us, what we could do instead is we can look at the rate of change of the numerator and the rate of change of the denominator. And this becomes the limit as x approaches 1 of what is the derivative of natural log of x? 1 over x divided by what's the derivative of the denominator? Negative 1. So now what we have is the limit as x approaches 1 of negative 1 over x. Now I'm going to try to plug in the 1. I plug in the 1, and what do we get? Oh, what you're approaching? Yep, you could approach 1, you could approach 10, you could approach infinity, you could approach all sorts of different values. But if you come up with the indeterminate form of infinity over infinity or 0 over 0, then apply L'Hopital's rule. Let's try another one. Limit as x goes to infinity of e to the x over x squared. If I punch in a very large number for e to the x, I get another very large number. If I punch in a very large number for x squared and square it, I get another very large number. So I get infinity over infinity. I don't know how to solve that. So therefore, I apply L'Hopital's rule. The derivative of the top, e to the x, derivative of the bottom. I go ahead and put in a large value, and I get infinity in the top. What do you get in the bottom? Infinity. Shoot, I have another indeterminate form. Do it again. I could be asking you to do something difficult, but fortunately, this is super easy. What's the derivative of e to the x? E to the x. You should be saying, thank you, L'Hopital. What an easy rule you've made for us. I'm going to stop my sarcasm of, oh my gosh, this is so tough. What's the derivative of 2x? 2. And I get infinity over 2, which is infinity. You get an indeterminate form, L'Hopital's rule. Simple. That's it. Example 4. Limit as x goes to infinity. Natural log of 2x over cubed root of x. Oh boy, this one's a little bit more confusing. Natural log of infinity. You don't even know how to think about that, do you? Do you know what the graph looks like? Oh. Graph looks like that. So as x goes towards infinity, y goes towards infinity. So the top is infinity. Doesn't head off as quickly as other ones do. And then the next one, cubed root function looks like that. As x goes towards infinity, y goes towards infinity. So again, it heads off rather slowly, but it does take off towards infinity. I don't know how to do infinity divided by infinity. So therefore, what I do instead is I use L'Hopital's rule. L'Hopital says take the derivative of natural log of 2x. You may know what the derivative of that is. over 2x. 1 over x then. We'll make the boxes natural log of u and 2x. Derivative of 2x is 2. Derivative natural log of u is 1 over u. We'll plug in the 2x for the u, and I get 2 over 2x. The 2's cancel. I have 1 over x. It is. The other way to think about it, this is the way I think about it, natural log of 2 plus the natural log of x. That's the same thing, right? What's the derivative of natural log of 2? 0. It's constant. Natural log of x, 1 over x. So, multiple ways of thinking about it. Whatever floats your boat, folks. What's the derivative of x to the 1/3? One over 3x to the 2/3. Multiply by the reciprocal. And I get the limit as x goes to infinity of and what is x to the 2/3 over x? Three over x to the 1/3. Now I let x go to infinity. What happens at the top? 3. What happens at the bottom? Infinity. And what is 3 over infinity? So okay, so 1 times 3x to the 2/3 is 3x to the 2/3, right? And 1 times x is x to the 1 or x to the 3/3. Okay, example number 5. Let's plug in 1. I have the natural log of 1 quantity squared. What is the natural log of 1? 0. And then I have the cosine of pi x. What's the cosine of pi? -1. Is that an indeterminate form? No, it's not an indeterminate form. So I don't need to do L'Hopital's rule. What is 0 divided by -1? Should be a 1 plus cosine of x. You try the next one on your own. Go. Folks, what's the years? No, none. Okay, so you get 0 over 0, correct? And now you have the limit as x goes to pi of cosine of x over 1 minus sine of x, don't you? And as you go ahead and you type in pi, what's the cosine of pi? Divided by 0. Uh-oh. That's not an indeterminate form, is it? But do we know it? No, it doesn't work. You have to have 0 over 0, or you have to have infinity over infinity. Is it? I think that we can make an argument for what this limit may or may not be. It is not necessarily undefined. It is not necessarily does not exist. We need to consider this a little bit more carefully. However, fortunately for you guys, you are very intelligent and you know exactly what these graphs look like. So I'd like you to take a look at cosine of x and negative sine of x. What does a graph of cosine look like? Where does it start? Top, heads down. Everybody good with that? Did I lose anybody there? Yes. Yeah. We switched the problem to be positive. Okay, and then I have negative sine of x I'm considering. And negative sine of x starts in the middle, and it's going to start by heading down and up from there, right? Okay, so this is how you handle a situation like this. You need to consider the graph, you need to consider the direction that's heading and all those good pieces here. And so as I think of cosine of x over sine of x at the value of pi, this is where I'm looking at it, okay? Let's let x approach pi, the limit as x approaches pi, and let's start from the right-hand side. As I approach pi from the right-hand side, what is the output of the green function going towards? -1. Everybody agree it's headed, the green function is headed towards -1? Great. So I have -1 over, what is the blue function headed towards? 0. Now, it's headed towards 0. Are the values positive or negative as it's headed towards 0? They're positive, right? So they're headed towards 0, and they are positive as they're headed towards that direction. Everybody agree? So I'm going to write a really small positive number. If you take -1 and divide it by a really small positive number, for example, -1 divided by 1/1,000,000th, what are you going to get? Let's try on our calculator. Yep, you're going to get 1,000,000. So I'm going to take -1 and I'm going to divide it by 0.00000001. Okay, I'm going to take it, divide by a really small number. What do I get? A really big negative number. So everybody see that the limit from the right-hand side is going to head towards negative infinity. Well stated. All right, and now let's check the limit as x goes to pi from the left-hand side. Okay, let's start with the green function. What's the output of the green function? -1. And what's the output of the blue function? What's it going towards? 0, but all the values are negative. So from that side, it would be 1 over negative small number. What would be -1 divided by a really, really small negative number? Positive infinity. So if from the right it's headed to negative infinity, and from the left it's headed to positive infinity, what do we say about the limit? It does not exist. No, you would have to do that. I mean, you can't, you don't know otherwise. Thank you for asking. Suppose you had cosine of x over x squared. Cosine at top is always headed towards +1. And x squared is always headed towards 0, right? And if you look from the right side, it's 1 over a very small positive number. If you look from the left side, it's 1 over a very small positive number. So either way, you end up with infinity. So if you get 1 over 0, it might be does not exist. And I know the gasp that you guys all gave, you're like, oh my gosh, we could have just said that. No. No, I would not have done that to you. Had it been actually, you could just write does not exist all the time, I would tell you that because that's how I operate. But because that's not the case, it could be does not exist. It could be infinity. It could be negative infinity. It could be different options. You must then consider what I told you to. I do not desire to create more work for you. I desire to tell you exactly what you need to know for calculus. Yes. Here we go. 2 examples left. How do I start example 7? I plug in 1, and I get the limit as x goes, or I'm sorry, as you plug in 1, we'll do that afterwards, but we plug in 1, what is 1 to the 5th? Times 14, minus 14, 0, divided by 0. That is an indeterminate value. We do not know what it is. What do? L'Hopital's rule, take the derivative of the top, the derivative of the bottom. It is a beautiful thing. What's the derivative of the top? Divided by 24x cubed. I try plugging in 1 now. You get? Again, it seems like a small thing, but note that when you walked into class, you had no idea how to take care of that. In fact, your whole lives, you have had no idea how to take care of 0 over 0. And we were able to take care of it just like that. Okay. All right, last example. Limit as t goes 0 of e to the t minus 1 over t cubed. I plug in 0. What do you get? I get 1 minus 1 over 0. I get 0 over 0. I cannot come up with an indeterminate form, so therefore I use L'Hopital's rule. What's the derivative of the top? Over 3t squared. I plug in 0. Anything 0 power is 1 over 0. Goodness, 1 over 0. I don't know what that is. Fortunately, I know exactly what these graphs look like, don't I? What does e to the t look like? It is an exponential function that passes through the value of 1. What does 3t squared look like? E to the t. I'm going to approach 0 from the right. What is the output approaching? Positive 1. What is 3t squared approaching? 0. All the values in both situations are positive. So you get a positive 1 divided by a very small positive number. What will be 1 divided by a very small positive number? Infinity. I go from the left. E to the t is approaching 1. 3t squared is approaching. It's approaching 0. It will be a very small. Is the number positive or negative? It is positive. Are the limits the same? So therefore, the answer is, you saw a situation where the limit did not exist. You see this situation where the limit definitely does exist. If you get 1 over 0, you cannot say does not exist. You need to check the graphs and consider that extension. I have your last assignment for you.